I've now attached 2 more disks to this virtual machine, and now I'm starting it up again. So you can attach the disks to Hyper-V virtual machine with the following commandlets. You can run new VHD path, the path to this virtual disk, for example, in my case it's D drive, VM folder, disks, and you name it, for example, disk1.vhdx, size, and then the size bytes parameter followed with the size you want to specify. For example, I add 3 virtual hard drives, 1 GB each. And then you add this newly created virtual disk with add VM hard disk drive commandlet with parameters VM name, for in my case it's lit srv1, and path to the disk. So I'll add the credentials here, and let me launch ISC and show you the commandlets, the one-liners to add virtual disks. So I'll launch it as administrator. Let me paste them, make it larger. And as you can see, these are the commandlets to add virtual hard drives to your virtual machine. Now, if we launch Tools, Computer Management, Disk Management, we'll get 2 more disks attached. But again, I've got this only 1 disk attached, disk 2. Okay, I'll press OK. And the third one didn't want to be initialized automatically, so as you can see, it is offline right now, and we can press right-click it and bring it online as well. Now we can create dynamic disks out of these three disks. And by the way, you need to initialize it again. So I'll right-click it, initialize, disk 3 MBR. Now, another question concerning disks is selecting a file system. So there are different file systems, and we start with FAT. FAT file system is the most simplistic of the file systems that the Windows operating system support. The FAT file system is characterized by a table that resides at the top of the volume. We don't use it that much right now, but you have to know about this file system. So to protect the volume, 2 copies of the FAT file system are maintained in case one becomes damaged. Additionally, the file allocation tables and the root directory must be stored in a fixed location so that the system's boot files can be located. A disk formatted with the file system is allocated in clusters, and the size of the volume determines the size of the clusters. When you create a file, an entry is created in the directory, and the first cluster number containing data is established. So let's go ahead and right-click this disk 1, click Properties, click Volumes. We can see that it's a basic disk, it's online, it's got master boot record, and if we right-click it again and click New Simple Volume, click Next, we have to specify the volume size. Let's use all of it. Assign the following drive letter to this disk drive. And now when we've got this new simple volume wizard format partition window, we can label it. For example, we can name it TMP, and we can select a file system, which is FAT, FAT32, NTFS, ReFS. So let's try selecting FAT, and that's how you select file system for the disk. There is no organization to the FAT directory structure, and files are given the first open location on the drive. Because of the size limitation with the file allocation table, the original release of FAT could not access partitions that were less than 2 GB in size. To enable larger disks, Microsoft developed FAT32, which supports partitions of up to 2 terabytes. So if we click here FAT32, it'll be a bit upgraded version of a FAT. And the partitions, it supports the partitions of up to 2 terabytes, FAT32. FAT does not provide any security for files on the partition. You should never use FAT or FAT32 as the file system for disks attached to Windows Server 2016 and above versions, or 2022. However, you might consider using FAT or FAT32 to format external media such as USB flash media. The file system designed especially for flash drives is extended FAT or exFAT. You can use it when FAT32 is not suitable, such as when you need a disk format that works with television, which requires a disk that is larger than 2 terabytes. A number of media devices support exFAT, such as modern flat panel TVs, media centers, and portable media players. The next file system is NTFS. If we go ahead and click NTFS, we can format it with NTFS as well. By the way, if we choose FAT32, you can choose allocation unit size here. And as you can see, it starts with 512 and finishes with 256K. And if we choose NTFS, it starts with 512 and finishes with 2 megabytes block size. So NTFS is a standard file system for all Windows operating systems, beginning with Windows NT Server operating system. And unlike FAT, there are no special objects on the disk, and there is no dependence on the underlying hardware, such as 512 byte sectors. In addition, in NTFS, there are no special locations on the disk, such as the tables. NTFS is an improvement over FAT in several ways, including better support for metadata and the use of advanced data structures to improve performance or reliability and disk space utilization. Now, NTFS also has additional extensions such as Security Access Control Lists, ACLs, which you can use for auditing, file system journaling, and encryption. NTFS is required for a number of Windows System Server roles and features such as Active Directory Domain Services or ADDS, Volume Shadow Copy Service, which is VSS, Distributed File System, and File Replication Service. NTFS also provides a significantly higher level of security than FAT or FAT32. And if we check this disk 0 here, it is formatted with NTFS. We've got properties for disk C. You can find shadow copies here because it's NTFS file system. Security, quota, all this is thanks to NTFS file system. And we go ahead and continue, and the next file system we've got is ReFS. And you can see the volume, the allocation unit size here starts with 4096, so it's 4000 bytes, and it finishes with 86 kilobytes size block. So Windows Server 2012 first introduced this ReFS to enhance the capabilities of NTFS. ReFS improves upon NTFS by offering larger maximum size for individual files, directories, disk volumes, and other items. Additionally, ReFS offers greater resiliency, meaning better data verification, error correction, and scalability. You should use ReFS with Windows Server for very large volumes and file shares to overcome the NTFS limitation of error checking and correction. However, you cannot use ReFS for the boot volume. Please remember this. And some words about this sector size. When you format a disk using a particular file system, you must specify the appropriate sector size in this Format Partition dialog box. The sector size is described as an allocation unit size. You can select from 512 bytes, as I said, through to 64 kilobytes. To improve performance, try to match the allocation unit size as closely as possible to the typical file or record size that will be written to the disk. For example, if you have a database that writes 8,192 bytes records, the optimum allocation unit size would be 8 kilobytes. This setting would allow the operating system to write a complete record in a single allocation unit on the disk. By using a 4 KB allocation unit size, the operating system would have to split the record across 2 allocation units, and then update the disk's master file table with the effect that the allocation units were linked. So much more work to do, and it's better to plan overhead your allocation unit size. By using an allocation unit at least as big as the record, you can reduce the workload on the server's disk subsystem. Be aware that the smallest writable unit is the allocation unit. If your database records are all 4,096 bytes and your allocation unit size is 8 kilobytes, then you will be wasting 4,096 bytes per database write, so half of it, twice more work.